Welcome to another video on quality management tools. As a part of our 7 QC tools video series as well as Minitab tutorial video series, I was planning to upload videos about control charts for quite some time. But because control chart is a very important topic and also it have a lot of subtopics like what kind of control chart to be drawn for what kind of data type, and individually for each of the control charts I have to post a video. This topic of control chart was delayed for some time. I think it's appropriate time now that I should upload videos on control chart. Hence, I decided to upload this video. So in this video, we will understand the introduction of control chart, what control chart is all about. And in my subsequent videos, I will give you details of every single type of control chart, under what circumstances, what kind of data type, each of those control charts need to be drawn. Let's get into this video. As I was explaining, this video is an introduction to control chart. What is control chart? Subsequently, we will see the other sub videos on control charts. To start with, control chart is a graphical representation which helps us to visualize variation with respect to time. Control chart is also called as Shewhart chart because Walter A. Shewhart is considered as father of control chart. He gave this graphical representation of analyzing common cause variation and special cause variation with respect to time in a graphical format. That's where the control chart as a concept evolved. This control chart is also called a statistical process control because it gives you an understanding of whether a particular metric of your process is within the statistical control. So what do we mean by statistical control? We will understand about in this video. To start with, as I was explaining in the beginning, control chart is a graphical representation to understand variation with respect to time. So when we say graphical representations to understand variation, there are certain charts that immediately come to our mind, like histogram, box plot. So these are graphs that we already used. We have videos about it, how box plot helps us to understand variation, how histogram helps us to understand variation. I'll be sharing the links of those videos also in the description of this video. However, a line chart is a slightly different chart compared to these two charts I discussed. Box plot and histogram, compared to that, line chart is a slightly different chart. Why? Because a line chart will help you to understand variation, but with respect to time. It is a time series chart. So what do we mean by a time series chart? A time series chart is a one where you will measure data in a chronological order. That means with respect to time. Day 1, day 2, day 3, temperature of Chennai, or hour 1, hour 2, hour 3, humidity of a lab. So what are we doing? We are measuring a particular metric, which could be temperature, humidity, dimension, whatever could be the metric. We are collecting this data with respect to time, and we are plotting the data also with respect to time. So when you do that, what you get? You get a line chart. A control chart fundamentally is a line chart, but with few more components added to it, we construct a control chart. Control chart is an extension of a time series line chart, but with few more components added to it, we create the control chart. So what is the difference of plotting a chart to measure variation with respect to time and variation with respect to position? When I say position, where is your average or where is your central tendency, and from that central tendency, how far is your data away from the central tendency, how much of data is concentrated closer to the central tendency, how much of the data is spread far away from the central tendency. This is analyzing variation with respect to position. Whereas when you try to draw a line chart, you are analyzing variation with respect to time. So there is a difference between these two. So from that perspective, we will understand what is the difference, how to analyze or understand this difference, right? So for a minute, let me take you to Minitab, where I have a specific set of data. This is pH value of a process where they make detergent. So from that detergent, they take the pH value. So these are data points taken one after the other. At this point, it's too early to get into I chart, X bar R, X bar S, these kind of terminologies, individual moving range chart, average and range chart, average and standard deviation. It's too early to get into all these kind of nuances of control chart. To start with, we will consider this as a variable data. right? Continuous data collected one after the other. Now, if I want to understand the variation, I can click on graph, I can go to histogram, and I can go with a fitted line, and I can say I want a histogram for the pH value from this process of making detergent. And here I got the data, and this data is with respect to a position. You have a central tendency, and from central tendency, how much is your data point away from the central tendency. That is how this graph is constructed. Now what we will do is, for the same graph, what we will do is we will also construct a control chart. To start with, I'm going to construct a control chart as individual chart, eye chart. Why eye chart? All this we can come later, but however, let me draw a eye chart. I'll explain about each of this as we move on. So this is an eye chart, which is a control chart. Both for the same data, we have drawn this. Now how to make a context out of this, right? So what I'm going to do is I'm going to copy this control chart to my PowerPoint presentation. I'm going to take this to my PowerPoint presentation. So here you will see the same graph, the eye chart is being copied. The same chart I have drawn in my Minitab, that chart is being copied. And what I have also done is I have copied the histogram for the same set of data. This histogram is being copied, and this histogram is also taken to the PowerPoint presentation, but I have changed the orientation of the histogram. I have rotated the histogram in such a way that the scale of the histogram is in line with the scale of the histogram is in line with the scale of the control chart. So if you see here, the scale of the histogram is in line with the scale of the control chart. And now if you see here, what happens? Histogram gives you the variation of data with respect to the position, whereas control chart gives you variation of the data with respect to time. So just to make you easy to understand, let me get back to the slideshow mode. This is the chart that we are talking about, and here if you see the data point, I'm trying to more or less try to align this scale with this scale so that you would be able to make a context out of it. So here is your central line, here is the average of the process, and here are data points which is more or less closer to the average. You will see a lot of data points closer to the average. You will see few data points far away from the average. So this single data point, this double data point represents this bar chart, and this one out of control data point represents this bar chart. So this is a difference. A histogram gives you a positional view of variation in your data, whereas a control chart gives you a chronological view, or a variation, or a view which gives you variation with respect to time. So this is how we can differentiate between a histogram and a control chart. Okay, coming back to the introduction of control chart. As you see here, a control chart is always a combination of line chart with few other components to it, as I told before. So how do we construct a control chart? We construct a control chart by collecting historical data of a process. From that historical data, I calculate the process average, which is your central line, which is your X bar. And from this process average, I calculate my upper control limit and lower control limit. These are two lines calculated based on the variation in your process. If you can recollect, as per the normal distribution curve, if you have your average, and if you have 3 times of standard deviation from your average plus, and 3 times of standard deviation from your average minus, that is average plus 3 standard deviation and minus 3 standard deviation, if you try to draw these two lines, if your data is normally distributed, 99.7% of data should fall within these two lines. If a data point is not falling within these two lines and it's going beyond these two lines, then what we can consider that? We can consider that as a special cause variation. If there is variation but within these two lines, then what we can consider that? Then we can consider that as a common cause variation. That means a process definitely will have inherent process variation because of all these 6 M's. Man will cause some variation, machine will cause some variation, material will cause some variation. So these 6M cost variation is what we generally call as common cost variation. And anything beyond that, something abnormally happens, then that day the process can have a extremely higher variation, and that is what we generally call it as a special cost variation. So by drawing a control chart, you will be able to distinguish between common cause variation and special cause variation. Definitely there will be variation, but is that variation because of common cause or is it because of special cause? And if a process is having only common cause variation, not having special cause variation, then we call that process as statistically stable. That's what we called this chart as statistical process control chart. Why do we call it a statistical process control? Statistically, the process did not have any special cause in a particular period of time. Then we call it in control. If there are special causes, then we say the process is out of control, right? So that's why this chart is also called a statistical process control, because you are able to see whether your variation in the process is within the control limits or outside the control limits. And as I told, the formula or a very high level way of explaining how these control limits are drawn. These control limits are drawn average plus 3 times of standard deviation and average minus 3 times of standard deviation. If the standard deviation of my process is very small, then these control limits will be closer to your x bar. If the standard deviation of my process is higher, then these control limits will be far away from my central line. So that is why this chart is also called as voice of process. The control limits are basically telling you the amount of variation in your process. If your process have a lot of variation, the control limits will be far away. If your process has less variation, the control limits will be closer to your x bar. So a control chart is also called as voice of process because it tells you exactly what is the variation in your process. As we move on, what is the basic procedure to construct a control chart? How do I construct my control chart? The first thing that I need to do is I need to identify the metric or data for which I wanted to draw this control chart. Once I identified that metric, then I collect that means I need to choose an appropriate control chart. What do I mean by choosing an appropriate control chart? Let me again get back to Minitab for a minute. So if you see here, if I click on stat, if I click on control charts, there is a lot of control charts available. You have control charts for variable data collected in the form of subgroup, variable data collected in the form of one after the other individually. You have attribute charts like charts for defects, attribute chart for defectives, with a constant subgroup, with varying subgroup. So there are a lot of different control charts available. In fact, as part of this control chart series of videos, I'll be explaining about each of these control chart in my subsequent videos. So coming back to the PowerPoint presentation, the first thing that I need to do is I need to decide the right control chart that need to be used for a given scenario and given data type. And then I need to decide what is the time period from which I am going to collect data, with which I will calculate my central line and control limits. Last 30 data points, last 100 data points. So there is a thumb rule that it is better to collect the last 30 data points as your appropriate time, or last 90 data points. So these, what should be the right time period, depends on industry to industry. So you can consult your Lean Six Sigma Master Black Belt depending upon your industry to decide what is the right time period. And once you collect your data point, then you should be able to construct your control chart. So today there are a lot of softwares available for you to construct your control charts. You can do it even in Microsoft Excel. You can do it in softwares, different softwares. One of the softwares which I am going to use as part of this video is Minitab. So you can use one such BI tool, that is business intelligence tools or data visualization tools, and you can construct your control chart. As you construct your control chart, you need to be very careful on 3 formulas. What are the 3 formulas? The 3 formulas are: how do you plot your central line? For any given appropriate control chart, what is the formula to calculate the central line, which will be the central tendency of your process? How do you calculate the upper control limit? How do you calculate the lower control limit? Once you are very clear about these 3 formulas, then constructing a control chart is not that difficult. So softwares do this by themselves, like I was showing in Minitab. The control limits, the center line are calculated by the software itself. But when you are doing it in Excel, you need to be very clear on what formulas you are using to plot your central line, upper control limit, and lower control limit. And once you are clear on this, once you constructed this control chart, then you need to start plotting your data on the agreed frequency. The frequency can also be decided by your process expert because the frequency changes from process to process, but it is with respect to time. So you collect data with respect to time and start plotting the data with respect to time. And once you start plotting the data with respect to time, you will be able to identify statistical process abnormalities. That means when your process goes outside your control limits, or when your process is under the influence of any special cause, the control chart will help you to identify that, so that you can immediately investigate and understand what actions need to be taken. So this is how you construct and start using control charts. And when to use control charts? Control charts can be used for an ongoing process to see whether it is under statistical process control. If at all there is any breach of control limits, you can consider it as a incident and you can start working on it. Control charts can also be used to predict the outcome of a process and see whether the outcome will go beyond customer specification limits or customer requirements. Control chart is an early warning system. By using control charts, you will be able to understand if there is something wrong in the process much faster. And again, as I told, control charts will help you to understand the stability of your process, whether your process is stable with respect to the statistical data points that you are collecting. Control chart helps you to analyze patterns, and if there is any kind of special cause or a repeat of a particular pattern, you will be able to understand that by drawing control charts. So as I told in the beginning, it gives you a segregation, or it gives you to differentiate between common cause variation and special cause variation in your process. And similarly, if you are involved in a quality improvement project, a DMAC project, or some kind of a continuous improvement project, you can again use control chart as a graphical representation to show the before and after stages of your process and see how your process is improved with respect to the output metric. So that's also one way of using control chart. So friends, I hope this video was useful for you to understand what is control chart, how it is different from other charts which is used to represent variation, when to use control chart, how to construct a control chart. So I hope this video was useful. In our upcoming videos, what we will see is we will understand about these kind of different control charts. As I was explaining, there are a lot of control charts available. So which control chart to be used under which circumstances, that is what we are going to cover in our upcoming video. As you see here, the first decision making criteria is the type of data. Are you dealing with continuous, or in other words, you are dealing with a variable data, or you are dealing with a attribute data? And within continuous, how do you select your data, or how do you collect your samples one after the other, or you collect it in the form of subgroup? If you are collecting it in the form of subgroup, what is your sample size? Based on that, your control charts changes. And similarly, if it is an attribute data, again, whether it is a defectives data or defects data. In other words, whether your distribution is binomial or your distribution is Poisson. Depending on that, the chart type changes. And within binomial, are you collecting subgroups at the same number of data points every time? Or in other words, it is a fixed subgroup or it is a varying subgroup. And similarly, for Poisson data, it's a fixed subgroup or varying subgroup. Depending on that, your chart changes. P chart, NP chart, U chart, C chart. So you have a list of charts that you need to understand in this. So as I was explaining, my upcoming videos will be about each of these individual charts. I hope this video was useful. So I will be sharing the link of some of the previous videos that I discussed about with respect to variation. How do you want to graphically analyze data with respect to variation? And in my upcoming videos, I'll be explaining about each of these individual control chart. Thanks for your time. Thanks for watching this video. For more video on quality management tools and Minitab tools and techniques, please subscribe to our channel. Thank you.